Welcome to our last lesson on editing. And for this last lesson, we're actually not going to edit at all. We are done editing and we are going to export our edit into a file. And that file is going to be made into a DVD or put on the web or something. So how to do that? Well, today we're going to start with Premiere because we've been starting with Final Cut every other day, and these options are actually quite different between Final Cut and Premiere. And Premiere, I think, does a better job, so let's start with Premiere first. We've looked at this a little bit. You go to File, you choose Export, you choose Media. We've looked at exporting a file before, but we haven't really gone into depth. Today we're going to get really deep into this. Now we're going to do it in both editors, and we're going to look at exporting source files and encoding in other programs. And we're also going to look at exporting directly from the editor in case you know exactly what format you want. You only need that one format or a couple of formats, and how best to go about that. So let's start with that source file. To make a source file in Premiere, we've already done this before. You match the sequence settings, you queue it up, and then you click export, and out it goes. So we're going to queue up a source file because we want one of those. And that's going to bring up Adobe Media Encoder. Come on, Adobe. Well, we won't wait for it. We want to also export in other formats. So let's take a look at what we can do. You have a bunch of options here. Yeah, okay. You have a bunch of options here. You can export into the various formats that are supported by Adobe Premiere. You can also use any format that QuickTime supports. So if you want to do a QuickTime MOV, you can choose your codecs, and then you can select those specific settings. This is a preset, and this is actually your codec. So pick up what you want. You have options to anything that's installed in QuickTime. If you want to make an MOV file that uses H.264, then select H.264. Alternatively, you can go ahead and choose H.264 here as an actual format, and it will create an H.264 file wrapped as an MP4. You can use presets for all sorts of stuff. You can these are good for YouTube, Vimeo, whatever, what they're expecting. And let's just select the YouTube version. There we go. And it fills in everything for you. You can see that it's a MP4 file, but you can also change that to 3GPP, which is the past standard for phones. I mean, it is for some older phones, but for newer phones, we just use whatever they support, usually H.264 MP4. You can add your filters. We've been over all this stuff before. The codecs, this is all filled in for you because of Adobe Premiere's excellent presets. And then if you want to FTP it somewhere, there's that option as well. So if I want to take a look at this and what it looks like as an output file, not a big difference. It's kind of hard to tell because it's fit in there. Let's move to 100% so we can see the difference between encoded and not encoded. Oop. Not encoded, encoded. Not a huge difference. So I'm going to go ahead and queue this one up too, and that's going to get added to Adobe Media Encoder CS5. And now you can see I have just been queuing all these up, and I can go ahead and start the queue, and then it will encode into those formats. Now, one thing we're going to look at in a little bit is what bit rates to use, how encoding kind of works, and what you want to do when you're encoding for a specific format. We're not going to do that right now because I just want to get through the basics of queuing up files, encoding to formats using presets, and then we'll look at what you want to do for the web and so on. For the most parts, these presets are going to do what you want. You are not going to have to worry about entering in your own. But if you want to, we're going to talk a little bit about how to do that so you are all set. And before this encoding starts, I'm going to stop this video and we're going to move over to Final Cut and do the same thing. And here we are in Final Cut Pro. We are going to start exporting. To make a source file, we've done this already. You go to Export in the File menu and choose QuickTime Movie. You go ahead and do this. The important thing is that it's self-contained. It doesn't have to be, but I would recommend it. You name it and you click Save. You can recompress all frames if you want to, change the format if you want to, but for the most part you want to stick with what you're editing and just save it out as a source file. So that's it. That's all you do. It will then, let's just take a look at what it does. When you hit save, it's going to bring up a little dialog. It's going to interrupt any work that you're doing in Final Cut. You're kind of like stuck with this for a while until it's done. It usually goes pretty quickly, but because I have nothing rendered, it's looking at like 14 minutes. I'm going to cancel that. We don't actually need to sit here and watch the whole process go down. It's not very exciting. The other option is exporting to QuickTime Conversion. Actually, that's not the only option, but we'll get there in a minute. QuickTime Conversion will let you convert to any format. We've been over this as well. I think I just selected the wrong option. Let's try that again. No, I didn't. Okay. Never mind. It just looks the same. So here we go. We have some more options. Instead, we're exporting to a QuickTime movie, and you can use any of the QuickTime presets that are built into QuickTime. So you can go to iPhone, Apple TV, iPod, whatever some of these other ones are. There's iPhone, the cellular version for delivering over the airwaves, cellular airwaves, that is. MPEG-4, which will let you deliver an H.264 or MPEG-4 file. Apparently, it actually will not let you do that unless you select this, and then you can select H.264. Anyway, you have a bunch of encoding settings. We're going to be going over, again, encoding settings in a little bit. But here are all your options. If you want to make a QuickTime movie in a different format, choose QuickTime Movie. Options, you have access to all sorts of codecs, all the same ones we saw in Adobe Premiere. And you can choose your sound settings. This is uncompressed. This is the compression you probably want to use. AAC is kind of the standard compressed codec these days for Apple. And that's that. So those are your settings. You hit save. It will compress your movie in a new format. This takes longer than the previous method we just looked at. Let's look at one more that's a little bit more similar to what you did in Adobe Premiere. This is under the Send To menu, and you choose Send To Compressor, which is a piece of software that comes with Final Cut Studio. So I choose Send To Compressor. It's going to open up another program, much like Adobe Premiere opened up Adobe Media Encoder. And you're going to see this thing pop up here. This is sequence 1. That was what we were editing. And there it is. There is the actual sequence in Final Cut, which we can move around in slowly and see, yes, that is it. Apple has a bunch of presets in Compressor, so this is going to be a lot like what we just did in Premiere, and you can choose all your options. You can use QuickTime formats, and these are mostly editing formats, but you also have H.264. There are other workflows, just getting into other, this is like if you were going to use Compressor for creating footage that you're going to edit, but we're not. So if we need an MP3 for podcasting, we can use Compressor to just make that. But we've got a video here, and we want to make it for the web. So if we want to do a download, there are a couple of options here. You have H.264 at varying bit rates. You have a web video cast, more H.264. There's a YouTube sharing option that will give you a good source file for YouTube. And then when you want to use any of these, you just drag it here. And then want another one, let's drag another one. And so you can make tons of files. This is what's great about going directly to Compressor or using a source file. I like to use a source file because I don't like using Compressor. I don't think it's the very best compression program you can get. But if you do want to use it, you can go directly from Final Cut without having to save out a source file. So it saves you a little disk space and some time in terms of all the multiple exporting things you have to do. So then the other thing you have to do is choose a destination. By default, it's just going to save it in wherever the source is. In this case, that's the Final Cut project. But you have some destinations that are automatically made for you. The desktop, the source location, which it's sent to. Your user's movie folders, which is the movies folder in your home folder. Or cluster storage, which you would have to have set up with Final Cut for that to work. You can also add your own, local or remote, and you just select one of these and either enter the path or select where you want it using the file browser. So we're just going to leave it as source. When you're done, you just have to submit the batch. Now we don't have a batch, we just have one thing in here, so I mean, I guess it's technically a batch because we have two different options, but when you're ready to go, you can go in and add some more sequences so you have a bunch of them and then do everything at once and leave the computer alone. You just hit submit. It's going to pop up over here what's going on, and it will do the encoding, and when it's done it will let you know, and then you're done. And you've got all your files using these delivery options. One other thing to look at really quick though is we've been talking about the web primarily. Instead of just exporting to the web, you might want to export to a DVD. I'm not a big fan of DVDs and haven't been using them for a long time, and I think they're on their way out, and for the most part what you guys are probably going to be editing, you're not going to need to put on a DVD. But if you do, Final Cut Pro comes with DVD Studio Pro, and so you can encode footage for DVD Studio Pro like this. And you can choose how well you want to encode it, and that's just going to be the quality of the footage in general. This is going to be a fastest encode, and this is going to be a best quality encode. But you notice that they're the same times. There are two things that are going to factor into the quality of your DVD encode, and this is going to be the same in whatever you're using, so we're just going to talk about it here. You're going to be encoding an MPEG-2, and this is going to be a 2-pass encode, and that's why it says best quality, because it's going to take not twice as long, but close, because it's going to make 2 passes through the video to make sure it's making all the right choices. The codec is making all the right choices, that is. So it takes a little bit longer, and that's what's in the best quality folder. Fastest encode is a single pass, so it just makes a single pass, but it's still the same bit rate. So bit rate's the other thing that's going to factor in. Now you'll see in a 90-minute DVD, you have a bit rate of 6.2 megabits per second, and that's higher than, say, a DVD for 120 minutes, which has a bit rate of 5 megabits per second. And these are going to be the same in the best quality folders as well, because 2 pass versus 1 pass are the only differences there. When you're making a DVD, you have to, for most DVD programs, separate the video from the audio. So, when on DVDs you select an audio track in English, and then, maybe you want to change that to Spanish or Japanese or French or whatever. That's because the audio tracks are separate, so you can just swap them out. They're not connected like they sometimes are in a video file. So you need to add both a video and an audio preset to your source file. You can drag these both in. Oops, I just replaced one of the ones we had before, but whatever. And then you've got it all set for your encode, and then you submit that batch the same way, and then you'll be able to import that into DVD Studio Pro. We are not going to be going into the usage of DVD Studio Pro today because it is a lot. DVD Studio Pro is its own very complex application, so we're not going to be getting into how it works specifically. But in terms of preparing your media for DVD, you need to encode an MPEG-2. It's got to be less than 9 megabits per second in most cases. Most applications won't be able to handle it if it's more than that. And then you also need to encode your audio in one of the numerous formats that are supported on DVD. And numerous might be exaggerating a little bit, but generally you'll have presets for this. In this case, it is a Dolby codec, so you can get away with also using uncompressed PCM, AIFF, or wave audio in most cases. But here you can actually encode it, so it's not so huge, and you'll be using the AC3 format. So that's how you encode DVDs and encode web footage in Final Cut Pro and Compressor. Lastly, we are going to take a look at what you can do with encoding when you're actually getting deep into the settings and designing them yourself. To wrap things up here, we are going to take a look at what it means to actually encode a video, what we're doing in all the little compression settings, and so you can go in and make edits yourself to kind of tweak them to what you are looking for. These things change over time as standards change on the web, and standards for delivery on physical media change as well, so you need to keep up on that stuff. I mean, we just talked about encoding a DVD, and we've well moved on to Blu-ray, I suppose. I haven't personally because I'm not about the physical formats personally, but I don't have a Blu-ray encoder, so I can't really show you how to do that. But keep up on the formats and read encoding specs and all of those things, and you'll have an idea of what you need to actually know to encode video for those formats. We're going to look at some basics of video encoding right now using this application Episode, which is a standalone media encoder, much like Compressor, and it's made by the folks at Telestream, who also make ScreenFlow, which we talked about previously this week. And it has a lot of presets, so you could really get away with not ever getting into the settings yourself. So let's just, before we actually do that, take a look at what some of the presets are. If you want an MPEG-4 file for download, and you want it to be at 640 by 480, which we don't, but we're going to pretend we do. We're going to just drag it right onto there. A lot of encoders work this way. But let's say we wanted to make our own template. These are great. We can encode into various formats, more formats than are supported by Final Cut Pro. which is why you would actually pay for a separate encoder when you get one for free with Final Cut Studio. But if we want to make a template, how do we do that? This is going to be the same sort of thing for pretty much any encoder. We're doing it with episode because we have lots of options and we can talk about what they all mean. So I'm going to make a new settings file here, and we're going to use MOV as the output format because this is probably going to be the most common thing that you're going to export to outside of WMV and MP4. But MOV is going to give us the greatest number of options, which is why we're using it. So I have that selected here. Fast start for the internet because we might play this back on the internet. We will start by using H.264 as a codec and AAC as an audio codec. So H.264 is the video codec. I'm going to click the video tab. You'll see that there are a whole bunch of options for H.264, and this will be the case for lots of codecs. Now, what do these all mean? This is the peak rate, and this is the average rate. The average rate is basically the target bit rate you want to have. So let's say you have a bit rate of 1,000, because that's what we have set here. So let's go ahead and divide 1,000 by 8. That equals 125. So what does that number mean? That number means that's how many actual kilobytes each second will be in your video. So kilobits are 8 times the number of kilobytes. So every second of your video you're going to have an average of 125 kilobytes. So let's say your video is 94 seconds long. That means it's going to be 11.75 megabytes. So you can, on average. That's how you can determine. And this is using something called VBR, which is variable bitrate. If we want CBR, which is constant bitrate, we can just enter 1,000, and we will be assured that it will be exactly 11.75 megabytes when it's done, because we are saying use this bitrate no matter what. Now, why would you want to do constant bitrate versus variable bitrate? Variable bitrate will say, okay, you want it to be around 1,000, but if I don't need all of those 1,000 kilobits, then I won't use them. If you have like a picture of a blue square for 30 seconds of your 94-second video, I don't need 1,000 kilobits to display that. So I'm not going to use that. I'm going to use like 100. And other times you may have a really complex thing, like a landscape full of lots of flowers in different colors or something along those lines. In that case, you're going to want more data than 1,000. And so it's saying, okay, well, that's the average, but I need a little bit more, so I'm going to use a little bit more. And that's where this peak rate comes in. That's at 2,000. And you can't set that because we're in CBR. And variable bitrate using VBV is not going to. That's just going to set a buffer on how much higher and lower it will actually go. Using a peak rate, we'll say, okay, this is the average I want to pay attention to. This is as high as I'm allowed to go. So for a web video, you might want to say 1,000 kilobits is where I would like to keep it. Just keep it under 1,500 if you have to, though. If you have to go up, 1,500 is the max. So there are a lot of options you have. For the most part, when you're setting a variable bit rate, you're just going to be setting the average rate. And the buffer size is going to be set for you. You're not always going to have this many options. So that's an important thing to look at. For the web, 512 kilobits is generally what you want to target for a 768 kilobit per second DSL connection, or cable connection, but usually they're not that slow with cable. So that 512 kilobits per second for a 640 by 480 or 640 by 360 video is what you're looking at, or smaller. That's kind of the minimum for broadband. If you want to deliver something for HD, the minimum is going to be between 1,000 and 1,250 kilobits per second for 720p, and then you just kind of keep going up from there. If you want something that's going to look like DVD quality, that's going to be available for download, you're going to want to use something like 2,000 kilobits per second. I like to aim a little higher and go from 2250 to 2400. If you want a good 720p source file, I'd hit an average bitrate of 4,000 or higher. And when you're getting up to 1080p, which, maybe you should not be delivering that on the web yet because most connections can't handle it, but if you want to, you wouldn't be alone. There are plenty of video sites like YouTube that allow it. Then you want to deliver at a much higher bit rate, and that bit rate, I would say, is going to be at least 6,500 to 8,000 kilobits per second. And this is generally using the H.264 codec. You're going to notice that with older codecs, that bitrate isn't going to perform as well because the H.264 codec is more efficient. At 512 kilobits per second, it's going to look better than, say, the MPEG-4, the standard MPEG-4 codec would at 512 kilobits per second, because H.264 is just better than MPEG-4. It is actually MPEG-4. It is a variation of MPEG-4. It's just a better variation. It's an improved version. So you'll notice that your bitrate goes a longer way the better the codec is. And the nice thing about H.264 is that it is widely used and available, although there are arguments about whether that's going to happen or not for HTML5 video. We're not going to get into that here. At the time of recording this video, H.264 is the popular format, so that's what you're going to want to stick with. And these bit rates are going to be pretty standard. If anything, they'll just go down. As the codecs get better, you'll be able to lower them. So that's kind of how bit rates work, how variable bit rates work. Constant bit rates. Why would you want to use a constant bit rate? Well, when you're editing, a constant bit rate is good, especially with a keyframe for every frame. And we'll talk about keyframes in a minute. The constant bit rate is actually good for that purpose, because then everything's the same as you're going along. When you're editing, you want each frame to have a keyframe. You want each frame to be encoded, because when you do not have a keyframe every frame, in which case it's not really called a keyframe anymore, it's just a frame. But when you have a keyframe in different frames, it's basically saying, okay, frame 1 looks like this. This is a fully encoded frame. We're getting the full picture like a photograph. And then frame 10 will be another keyframe, and that will be a fully encoded picture, and you'll be able to see the full picture there. Frames 2 through 9, between those two keyframes, are not. All those are partial frames. What happens in frame 2 is what has changed since frame 1, and then it keeps what was in frame 1 already. And so you're only seeing the changes between the keyframes. You're not seeing a full frame. Constant bitrate doesn't change that, but having keyframes every frame will. Constant bitrate means that you're getting the exact same bitrate, that when you're entering an average bitrate, it's actually just going to be 1,000 kilobits per second. You're not entering an average, so I'm not sure why it says that. The reason you would use constant bitrate is for streaming. If you're streaming a video online, as in it's not, the difference between streaming video and progressive download is the key here. Progressive download is what you have on YouTube and most video sharing sites. And progressive download means you just download it as it goes, and it might, when you have the bitrate changing, it might slow down downloading in some areas because there's more data. Not every second is created equal. With constant bitrate, it is. You're always getting 1,000 kilobits per second. This might be at the degradation of the video quality at some points, and you also might be using more bits than you need at other points. But it is consistent, and when you're streaming a video to a source, you want it to be as consistent as possible. If that stream, if it's not really being downloaded, it's just downloading the necessary parts to stream that video, that means nothing's really, it's buffering maybe 10 seconds ahead, but that's about it. So if that bit rate drastically changes, then all of a sudden that connection may not be able to handle it. So you need to have a stream that is consistent. So if someone is on a 768 kilobit per second DSL connection, they'll be able to download that 512 kilobit per second video at 512 kilobits per second all the time. It won't be more, it won't be less, it will always be the same, and their connection as long as their connection performs adequately, it will be able to handle that stream. So the idea is to not make the stream too intense at any point in the video that the person you're streaming to, who you don't know who that's going to be, it could be anybody, but you want to make sure that they can handle that stream as long as their connection is at a minimum bit rate, which, for we're using at this moment to be 768 kilobits per second. Fortunately, most connections are faster than that, and you're probably not going to be streaming video. You're probably going to be doing a progressive download or putting it up to YouTube. So you don't have to worry about constant bitrate too much. You're probably not going to use it too much, but it's important to know what it is and why it would be used instead. For the most part, progressive download will do the trick. And if you did use a variable bitrate for streaming video, you can just set the buffer size really low, or the peak rate not too much different than the average bit rate, and then you're not going to have a lot of fluctuations, and you can still have some of the benefits just in a minor way for variable bit rates. So that's a lot of information. The same stuff kind of applies to audio, but it's a little bit more simple. You choose a bit rate, you choose your codec, in this case it's AAC, High efficiency and low complexity are things that you should know about with AAC. High efficiency is smaller and the quality is just as good at or I should say, the quality is better at the same bit rates. It's kind of like the difference between MPEG-4 and H.264. Low complexity has a much wider support. So most of the time you're going to want to use low complexity, even though you don't actually want to use low complexity. You want to use high efficiency, but low complexity is more supported. So if you can use high efficiency, that's great. But chances are you're going to be delivering to a wide audience, and high efficiency is not going to be widely supported. So that's basically how video encoding works in terms of bit rates and different methods of encoding. We looked at H.264. This stuff kind of applies to all different kinds of codecs and all different kinds of encoders. So this is a start. There's a lot more to learn in encoding. It's a very, very detailed science. I am not an expert by any stretch of the imagination, but I've been doing it a lot, and so I have a pretty good grasp on how it works in terms of delivering these formats online and for physical media. Now, if you want to really get into it, there's some excellent articles on Wikipedia that show you, if you just search for video encoding, search for keyframe, search for intraframe, INTRAFRAME, or interframe, which is INTERFRAME, you can learn more about the differences and how all this codec stuff works. If you're interested in it, it's really fascinating. If you're not, you're probably asleep at this point in the video because it can get really boring. It's really detailed. There are lots of numbers, and a lot of it is about really negligible quality details. But if you really want to get the best quality out of your video, experiment with different bit rates, experiment with different buffer sizes for variable bit rates. Each video is not created equal, so you might want to change your settings. Presets work well for the most part, but if you want your video to be encoded as well as possible, then you're going to want to set a specific bit rate for it and a specific buffer size or a specific peak rate for the variable bit rate, however you want to go about it. The one thing I'll leave you with is the better you shoot your video, the lower the bit rate can be. If you have good detail, if it's well lit, you can encode at lower bit rates and get away with it, and it will still look good. If you need proof of this, go download an episode of television and encode it with MPEG-4 at 512 kilobits per second, then take some crappy video you shot with your flip camera in a dark room, encode that, and tell me that it looks the same. You will find that dark video and video that doesn't have a lot of detail, video that's not well lit, will not encode well because the encoder will see the dark areas look very similar because there's not a lot of detail in them, and so they'll kind of blur together. It'll think it's just nothing, or it's out of focus or something like that. So encoders work better when you shoot your video well. Everything works better when you shoot your video well. Remember, weakest link is going to I don't even know what the saying is, but weakest link is going to ruin your video. So make sure that you do everything as well as possible, because down the line it is going to affect you again and again and again. And that's the most important thing I can leave you with these video editing lessons. This is it for our video lessons, although there may be a secret lesson coming up in the future about another video editor. But we will leave it here. And tomorrow we will be looking at mainly recap and additional resources, so you can learn a whole bunch more about all the stuff we talked about this week. So thanks for sticking with it, and we'll see you again tomorrow for additional resources.